In last video we see types of system call and video is too long, so we divide that video into two parts. One part is that types of system call, that file name dnpos24A, and this is another file dnpos24B. My dear students, we are seeing here operating system in this chapter 2, types of system calls. We see what is a system call and how that different examples of system calls. In process control, we see some system calls, and this is another file management. We see in detail in chapter 11 and 12, that is file system. We have to see here several common system calls available with files. One that to create and delete files, that create system call and delete system call, delete files. Either system call requires the name of the file or some of the file's attributes. Once the file is created, we have to open it and use it. We also use a read and write system call and reposition system call, that is rewind or skip the end of the file. Finally, we need the close system call, indicating that we are no longer using that file. We need some of these same sets of operations for directories if we have directory structure for organizing files in the file system. Either files or directories, we need to determine the values of the various attributes and perhaps to reset them if necessary. File attributes include the file name, file type, protection codes, account information, and so on. At least two system calls that get file attribute and set file attributes are required for this purpose. Some operating system provides many more system calls such as file, move, and copy. Other might provide an API that perform those operations using code and other system calls. And others might provide system programs to perform those tasks. If system programs are callable by other programs, then each can be considered an API, that application program interface, by other system programs. We see next here device management. A process has several resources to execute, such as main memory, disk drives, access to files, and so on. If the resources are available, they can be granted and control can be returned to the user process. Otherwise, the process will have to wait until sufficient resources are available. The various resources controlled by an operating system can be thought as devices, and some of these devices are physical examples such as disk drives. Others can be thought as an abstract or virtual devices such as files. A system with multiple users may require us to first request a device, then to ensure exclusive use of it. After we are finished that device, we release it. These functions are similar to the open and close system calls related to files. Other systems allow unmanaged access to devices. The hazard then is a potential for device contention and deadlock that discussed in detail in chapter 7. Once the device has been requested, that is allocated us, we can use read, write, and reposition the device just as with the files. Similarly, between I/O devices and files, there are many operating systems, including Unix, that Two or more combined file device structure. In this case, a set of system calls is used on both files and devices. I/O devices are identified with a special file names, directory placement, and file attributes. The user interface can be make files and devices appear to be similar, even though the underlying system calls are different. There is another example of the many design decisions that go into building an operating system.